Today's video, we're going to look at an introduction to logarithmic functions, or also called logs. A log is an inverse of an exponential function. So we need to be able to write from exponential form to log form and from log form to exponential form. What this is actually going to help us do later is to be able to solve exponential equations without having to graph them. So we're just going to do a really quick intro to this, okay? We're only going to go from one form to the other. So if you notice on the left in the log form, we have log, L-O-G, right? That's our abbreviation. And then we have this B number. It is small, it is a subscript. Okay, so that's how we're going to write it. That's our base of our log. And then we have the log base B of y equals x. And when you go and use those exact same values, the base value of b, the x and the y, and you were to write it in exponential form, notice our b is our base with our exponent of x equals y. So what I'd like to look at is the base stays the base, and then what our log was equal to becomes our exponent. Okay, so again, the b was our base in our log. It's also the base in exponential form. What the log was equal to, the x, is now the exponent. And then that other value, right, there's our y. That's where the y was from. All right, so let's practice rewriting problems that are in log form. So this is a true statement in example A in log form, and we're going to write it in exponential form. So first thing we do is identify our base, which is 3, so 3, and then it's going to have an exponent, so we have to decide, okay, what was the exponent, right? So we look over here, where was that exponent? It was what the log was equal to, so 3, so that's this one, 3 to the 4th equals 81, and that's actually true if you were to put that in your calculator. 3 to the 4th, actually we've talked about it, 3 to the 4th equals 81. So that is just writing it from log form to exponential, and that's it. That's all we're practicing today, is rewriting. All right, let's try example B. So again, we've got our base. So we look for the base. So our base, here's our base of 5. 5 to the, and then we need something for our exponent. 5 to what power? So remember, the log is equal to, this one is our exponent. Okay, so what the log is equal to. So 5 to the 0 power equals 1. And we know that's true. Anything to the 0 power equals 1. So taking a look, I just put the two forms. Log form is first. Exponential form is after it. And we're going to do the same thing. Okay, so same directions. So example C, we have our log, and it's got a base of 10. We have to decide what's our power. So remember, what the log is equal to, that is the power, that's the exponent. So 10 to the second equals, and then that other number was 100, and that's, again, true statement. And our last one of this type, find our base. So our base is 2 to the negative 2 power equals 1/4. And if we remember our rules for exponents, right, negative exponents, move it to the bottom, so it'd be 1 over 2 to the second, and that is 1 over 4. So we, again, know that really is a true statement. We know we are correct. Now, one thing that you might see is you might see logs without bases. So notice there is no little number right there. When you see that, that's called a common log. That means the base is automatically 10. So what this actually means is log base 10 of 10 equals 1. So I just wrote the little 10 in there as its base. And if you were to do this problem and you were to switch it to exponential form, then our base would be 10 to the first power equals 10. And it would also be a true statement. All right, so last thing we're going to do is we're going to go the other way. So this time we're going to go from exponential form and we're going to write it in log form. So I remember from the first two slides, I remember that log base b of y equaled x. And I remember we wrote it as b to the x power equals y. Okay, so let's rewrite this. So our base is 6, so log with a little base 6, a little subscript, and then we have to decide where the 2 and the 36 go. But I remember that I said that the log equaled the exponent. So here's our exponent. So I'm going to say equals 2. So that means 36 goes here. So this means 6 to the second equals 36. Log base 6 of 36 equals 2. All right, let's try the next one. So first thing, I find my base, right? My base is 4. So log, a little subscript of 4, base 4 of, and I identify my exponent. That's what the log is equal to. So that's way over here. So log base 4 of 1/4 equals -1, equals my exponent. All right, and our last one, see if you want to pause it and give it a try. Go ahead. All right, so let's see how you did. So my base is 10. So log with base 10 of 1,000 equals my exponent of 3. But remember, I did say that if you see, if you have log with base 10, you might see it written without the base. So you might have written log of 1,000 equals 3, and that is also correct, because when there's no base there, it's actually a base 10. And lastly, I just put a little picture of what it would look like on your paper with the lines. Since I don't have any lines on here, notice my little subscript, my base, right? Notice that is a little bit lower. It's not the same size as 81. It's lower and it's a little bit smaller. Just like our exponent of 4 in the next step is a superscript, and it's a little higher, but it's also smaller. So try to get it written like that so that when I see your papers, I can tell which number is the base, so the little one that's a little lower, and then which one number is, what are we taking the log of, the regular size number.